has the same, in equilibrium, the same markup and the same quantity, right? So there's just one markup. So the real effect are the markup times the change in quantity. And these are not mediated through prices, right? That's just a real effect. The second effect is pecuniary, which is that there's a change in prices multiplied by the quantities that each of the firms are producing. And that's purely pecuniary. That's something that the firm shouldn't internalize. Now, Dan, what would the planner want to accomplish in this market?
So the planner would want to have the firms account for real effects, but not pecuniary effects, because those are mediated by the price system.
Exactly. So they'd want to set these real effects equal to 0, right? Because that's the net impact of changing the firm's strategy through real things on the firm's profits. Absolutely. So they want to set m times dq equal to 0, right? On the other hand, what would a monopolist or a cartel want to do? Does anyone want to try to answer that? Yeah, they want the sum of the two effects on profits to be equal to 0, right? So they want m times dq plus q times dp to be equal to 0, right? So this leads to a natural definition of a conduct parameter theta, which is the ratio of m times dq over negative q times dp. So under competition, what is that going to be equal to, Chrissy? Zero, right? Because that's what the planner wants. That's what competition gives us. And it's represented by the fact that markups are equal to 0. And so this whole thing is going to be 0, right? And what is a monopolist going to set this thing equal to, Mohammed?
1.
Yeah, because if this thing is set equal to 0, then that's set equal to 1, right? So more generally, if we work this through and put it in the terms that we were talking about before, m over negative q times dq dp becomes m over q times p, m over p times dq dp over q times p, which is, this is the elasticity of demand. And so if we have this elasticity adjusted Lerner index, p minus mc over p times the elasticity of demand, that is exactly the conduct parameter theta. Okay. So this conduct parameter theta you can view as really summarizing everything that we've been talking about before, and all the other things about solution concepts and collusion are really just a way at arriving at a value for this conduct parameter theta. Yeah, Mohammed.
So this m dot dq that you're mentioning, is it for every firm or for like the total industry? Like,
well, yeah, that's a great question. So we're thinking about a symmetric model here. And so that's irrelevant. But we'll come back to that question in a bit. OK. So let's look at how the various models we've been doing so far fit in to this general framework. OK. So Vershang, how does Cournot fit in? What's the conduct parameter under Cournot?
Can you go back to the slide?
Yeah.
So Cournot is just price, the marginal revenue group. Price plus price prime.
Yeah.
So would you set that equal to that equal to the conduct parameter, and then solve for the.
Yeah, you want to solve for what the conduct parameter is under Cournot. And the question is, how can we do that?
So price minus marginal cost will equal P prime, the marginal revenue.
Yeah, P prime.
The Cournot distortion.
Yeah.
And then, so you have P prime is the inverse of PQDP.
Exactly.
So
So those cancel.
yeah, so you want.
So you get the.
You just get m over negative q, so you get 1 over n or something.
Exactly, because the quantity of the individual firm is 1 over n of the quantity of the industry as a whole. And so you just get 1 over n there. Right? That was very good. OK. How about under conjectures? Do you want to try to do that, Vishank? We can go back to the conjectures expression that Chrissy derived. So here's that. So the markup now is equal to this expression here.
Yeah, so you have, by learners, you have
Yep.
1 over the residual elasticity equal to that. And
Well, so here's the markup, right? The p primes cancel again, just like you did before, right? You get a 1 over n by dividing qi over the total quantity, right? And so that gives you 1 over n times this term here, right? This is 1 plus the aggregate reaction that you expect from everyone else. The increase in quantity that you get when you increase your quantity from all the other people, right? OK, how about differentiated Bertrand? Does anyone want to try to do that? Well, actually, maybe I'll just do it. OK, so under differentiated Bertrand, right, your markup was equal to the elasticity of your residual demand curve, right? And that's the same as negative your quantity over your price times the partial of your quantity with respect to your price, right? Now, we want to put this in terms of how much the total industry quantity changes when the price of all the firms change, right? So we can replace this with that and then say, well, what's the ratio of how much the total industry quantity changes when the price of all firms changes, divided by the number of firms, because we only had my individual quantity here, right, times this individual quantity, this individual elasticity. And so theta is the ratio of the elasticity of the industry demand curve to n times the elasticity of individual firm demand curves. OK. And that we can work through how to express it a little bit more. So note that the derivative of all firms' quantities with respect to the total industry quantity with respect to the price of all the firms divided by the number of firms is the same as how much any individual firm's quantity changes when all firms increase their price, right? And that's equal to how much my price changes, my quantity changes when my price changes, plus n minus 1 times how much my quantity changes when any other firm changes its price, because we're in a symmetric situation. And so that's the same as 1 plus n minus 1 times the derivative of my quantity with respect to other firms' prices divided by the derivative of my quantity with respect to my own price. And that term there is called the aggregate diversion ratio, or the negative of that is the aggregate diversion ratio. Why is it called that? Well, it says if I increase my price and I lose some sales as a result of that, what fraction of those sales are going to other firms in the industry versus to the outside good? Right? So this is how much do other firms' quantities increase compared to how much my quantity decreases when I increase my price? What fraction of the sales that I lose when I sell one less unit are recaptured or diverted to another firm in the industry? That's a natural measure of how closely we're competing, right? If we're not competing at all, right, and the diversion ratio is 0, then none of my sales that I lose will go to other firms. They will all go to the outside good. And in that case, theta, which is equal to 1 minus d, will be 1, and will be in monopoly even under Bertrand competition. On the other hand, if we're perfect competitors, if all of my sales that I lose get diverted to another firm, we're going to be in like undifferentiated Bertrand competition, right? And so theta will be equal to 0. OK. Now, in these two cases, theta is going to be pretty constant as we change the prices. While under differentiated Bertrand competition like this, theta will usually increase as prices increase. Why is that? Well, as the prices of the firms get higher, the goods within the industry are going to be less attractive substitutes for the consumers than will be goods outside the industry. And so as the prices get higher, a smaller fraction of the goods that exit will get diverted to the other goods in the industry. Yeah, Kentaro?
Yeah, so I just wonder, like, so for instance, between Kuhn model and conjectures model, which theta is bigger? I mean, it just depends on how good the complement or substitutes.
Between Cournot and conjectures, or you mean Cournot and Bertrand?
Well, first of all, Kuhn and conjectures.
Yeah.
Yeah. Then it totally depends on dq minus I over dqi, right?
Yeah. So it all depends on the reaction that I expect from other firms. Are we colluding, or are we sort of like doing the opposite? Like if I increase my quantity, you actually decrease your quantity.
That parameter depends on the substitutability or.
No, it depends on the nature of the collusion, roughly. I mean, or the way that firms are conducting each other. Both of these are undifferentiated models. Differentiated Bertrand is a differentiated model. But the main point that I'm trying to make is that all of these are ways of determining theta. So like Cournot with 5 firms is roughly the same as Bertrand with an 80% diversion ratio. That's sort of the point, right? And Bertrand with 80% diversion ratio is the same as a conjectural model with 100 firms and like 80% like expected collusion or something like that, you know, roughly. OK.
Can you go back to
Yeah.
the last bullet?
Yeah.
Is this like the cellophane fallacy thing where you raise price and things become more substitutable? Like, you know what I'm talking about?
No.
Oh, okay. There's an antitrust case with like cellophane, I think,
Yeah.
and they were trying to define the market for cellophane, and they determined that things were good substitutes at the given prices. But that was basically because cellophane was really good, and they jacked up the price to a point where consumers were about indifferent between cellophane and inferior substitutes.
I see.
Paper bags. So is this the